Hello Internet, this is JF, and this is Introduction to Programming in ATS. This is Video 8 and Chapter 8. And that chapter video synchronization may go out of sync once we get into this next book. But this particular chapter, Interaction with C, is pretty straightforward. I visited this chapter a few times just to refresh myself on, the actual interface when I was working with ATS and working with C, and I never really had a problem with it. It's not a chapter that I think you're going to have a lot of difficulty going through yourself. So I'm going to go through it pretty quickly for that reason. So one thing to point out is that ATS believes you. So the way that F5 works is that you say, okay, here's the name of a function, and here's the type of the function. So it's a size t, it returns a pointer. And that's the core of the FFI. Like, you just tell it about functions that are out there, and then the compiler believes you and says, okay, well, there's a malloc with this type, and you can go ahead and immediately use it. So obviously there can be bugs that arise from that if you get the type wrong, or like if it says malloc returns a string and you go and use it for strings, but you can also return null if it can also return null if it fails. So I think there are things like that get tricky. Especially with stuff like, what's a good example? I think Regex. So Regex takes a pointer to like a Regex type, it's an opaque type. And the obvious way to do that is to say, like, okay, extern fun, regcomp. And you want to say, okay, it's a reference to an undefined pointer and then an undefined Regex type, Regex T, after you do that. And I want to turn that into a defined Regex type and go on. But this is probably only the case if regcomp succeeds. So like whether or not it's really a regex after this function returns depends on the values of other types. So this type right here is strictly speaking it's wrong. And there are ways you can be more precise about it, but then it also becomes a sort of trouble in itself. It's like, wouldn't it be easier just to have a simple wrapper and then make safe regcomp that returns like an optional type or something. So you can do that. Okay, external global names. So use examples of how you say the functions exist. So this first one just says there's a function factorial that takes an int and returns an int. And the second one says, oh, by the way, the name of that factorial is fact2 in C. And then you can still implement this in ATS. You can like the very next line could be implement fact2 and then do like a normal ATS factorial. But the point is the name of the factorial in C is going to be fact2 in C, which helps with C calling ATS. And of course, if you do in fact go on to implement factorial in C and call it this, then when you call fact2 in your code, you'll be calling fact2 in C and C. I guess one thing to point out here is that So if you do have an extern fun fact2 and then factorial defined in C, there's no overhead whatsoever. So your code is the C code you generated just calls factorial in C with the types you have and takes the type back from it. And there's no kind of, it doesn't generate like a wrapper for you that turns things into other types. Like it's very efficient. It's not well, there are other languages that have the interface might look this simple in other languages, but usually they'll have some measure of overhead. They've got to do some work before you can actually use the function in the other language. Like I said, this is all pretty straightforward. Now above it used, so we're saying extern fun, and then you have a function type. And then you say it equals, you can say ext $, and then a name, or you can say mac $, and then a name. If you say ext, then ATS will generate a prototype. And if you're, let's say you do something like this. Let's say fact, and int equals mac2 fact in C. Let's say you say external like that, and then you go on to implement it. So okay. Int fact in C takes an int, and then you do everything here. So this is also syntax where it just embeds this C code in your generated code. So when you generate something, it'll just include this with it. And by the way, the way it works for languages other than C. Like ATS can also compile to JavaScript and PHP and Perl and Scheme and several other languages. The way it works is that you compile to C. So implement main and stuff that you wouldn't include this. You'd include like the runtime for the other language, or extern fun. Like you generate C code like normal, but you generate the kind of C code ATS generates. And something like this, you obviously wouldn't use C in this case. If you're compiling JavaScript, you would include like, function fact in C. Like you'd include like JavaScript code, and you would generate like a bunch of C mixed with JavaScript, and then there are translators that go through and understand the kind of C that ATS generates, and then they turn that into JavaScript, and the end result is a bunch of JavaScript, which is it's kind of interesting if you're wondering how that works. Oh, well, the point is about ext versus Mac is if you do this, then with ext, ATS will generate a prototype for your function, and if that doesn't match, then you'll get errors, warnings, or some kind of problem with C. So the C compiler won't be happy with you. So usually I just say Mac just because I don't really care that, like if it passes a string or something, it's not exactly that's not the syntax. That's not C syntax. It's not exactly like char or void char s. Like something I just want to say, just void s and take whatever kind of pointer it is. But then that's not going to match the prototype that ATS generates. So I just say Mac, and then Mac is exactly the same as ext, except it doesn't generate a prototype. And of course, there's also sta #, and then the name, and that'll give you a static function. And of course, if you exclude the name after the #, then it just assumes that you mean this fact. So whatever the ATS name is, like, oh, that must be the same name in C. There are also external types and values. So if you have something like regcomp, Regex. Yeah, if you have something like regcomp and you have like a regex t and you're like, what is that? How do I deal with that in ATS? You can just say, well, it's a regex t x type. It's x type with one t, so ex and then type or x type or something like that. And what is it? What is it again? Man regex. So it's regex t, and it's a pointer. I think that might be sufficient. It might be this or it might be that, but either way, you can do it like that and say and that's how I drop it. So you say var re, and then it's just it's an uninitialized, a stack allocated regex t, and then when the code's generated, it just says, oh, it's just a regex t that you stack allocated. So it's fine with that. And then you'd pass it to regcomp, and I'd use the reference form. So it would take a pointer to this. So yeah, I think it is regex t without the pointer then, because it would pass a pointer to this if you use the reference kind of syntax. So if you say extern fun regcomp regex t, and we did it like that. So this is stack allocated regex t of whatever that happens to be in the generated C code. So it's a struct or whatever. Then I'll pass a pointer to it to regcomp, and call it like this because of this, because of how you define this. And that actually works. So you have X type for C type, so you can just give them a name and ATS and use them directly. And then you see here the macdef is just used it's just a shorthand. So instead of saying null, or instead of saying like xval, it's a pointer. So xval is you give it the type and the ATS, so it's a pointer type. Its value is 0. Or it's a file ref type and the value in C. And this is the value in your target language. So yeah, I just want a 0 and the generated C, and I want that to be a pointer in ATS. So this gives you a shorthand. I think probably define, pound define will work just fine for these as well. And you can also use xval for functions. That's something I haven't noticed. But yeah, apparently you can do that. Normally what you do is just use that function call. So xf call, then the return type of the function, then the name of the function, and then your arguments. And you don't have to give your arguments types. ATS just goes by the actual type of your arguments, and it uses that for the function call. Let's talk about inclusion of external code in ATS, which is these symbols. This is for just drop the code directly in the, when this file is compiled, just include whatever's in here in that file. There's some cousins. Include this at the top of the generated file. Include this at the bottom of the generated file. And then here is include this in people who load me. So include this in style loaders of this file. So it's like if somebody style loads this file, they'll get this, and that'll be, so when that file is compiled, this will be included there. So that's useful for like header-only libraries. It describes that. And calling external functions in ATS, instead of using the FFI with extern fun and all that, you can just call them directly. Although it doesn't actually say that. So yeah, this is he's wrapping a function so it's local in, so he's defining a printf just for this one expression. So that's a thing you could do, but as a shorthand, you can use this xdef call. And I think if you're taking some C and you're wanting to turn it into ATS, let's say you have a small C project, and you're like, yeah, I'd rather have this entire project be an ATS. When you start interfacing with it, I'd kind of prefer to use xf calls and xvals rather than sort of defining everything, because usually you want to have more precise types than C really has. So rather than generate a bunch of interfaces that you're going to want to throw away and make more precise later on, you can just say, okay, I don't care what the arguments are, just call it and give it this. Or what types the arguments are, just call it very simply. It says, not only can you have C do your dirty work, but you can do your dirty work in ATS. So I'll read this part. ATS is probably not a programming language easy for one to write code in. While ATS provides many features to support safe, low-level programming, it may take a long time and some great efforts for a programmer to learn and master these features before he can make effective use of them. So yeah, if you're going to have proper dependent type theorem-proving code, then that's hard. That's hard. I'm doing this whole video series, and I started doing videos in ATS at all because I was having trouble myself. So in this section, I would like to present some ATS code written in the C style that makes typical use of certain unsafe programming features in ATS. So if you're familiar with C, you can just do this in ATS and it'll work. Well, it'll work as well as your C code would work. And an ATS is going to bug you about, you didn't prove that array dereference was okay. You're doing it unsafely. You're just going to go with it. And this gives an example of a strcomp written in an unsafe style. Well, let's look at that. How is it defined? So fun strcomp, it takes two strings and returns an int. So it doesn't really return an int, it returns you might want to be a little bit more precise about that, but whatever. I guess the whole point is we're not using the advanced features. That's why we're just going to do it in C, pretty much. So let's see, A and B. And then he says, defines a loop to go through care if I care. He also uses un. This is an abbreviation that's used throughout the book that you don't actually get normally. The Oh, see, he styles it right there. It calls it un. But if you just do an include, you still have all the unsafe stuff, but it's behind an unsafe rather than an namespace. All right, let's do that. I'll do it like this. So loop string to pointer. Okay, A. String to pointer, B. So loop is again, it takes 2 pointers. Unsafe, pointer 0 get, which pulls the ucar out of an unsigned char out of the first one. And you can just as easily say, unsafe get and a float or an int or whatever you wanted. Now this is really weird code. Like, I wonder if this was like written before if case or something, because I'm just going to use if case here. So he's using a case, but only for guards. So well, you just use if case. I think that's exactly the same. So unsafe, we're casting it to an int now. So we're saying if it's 0, how does steal equals 0 like that? By just C1. I don't know if there's a bug here. I'll just do it as he's got it written, and I'll try that out later. So loop pointer 0 suck ucar. So if you use int here, like this is obviously just like +1 and C, but +1 varies depending on the type of the pointer. So this would be like +1 to like avoid pointer cast a car temporarily, or something to make the ANSI make it not give you a warning about types. But if you did like int, obviously you jump forward 4 bytes. If you did like size t, you would jump forward 64 bits. So what, 8 bytes? So that's all low-level stuff. All right. So let's just test these out. Keyword equal sign is needed on line. What's that line? Line 50, line 5. What? Oh, extern. Can be resolved as no match is found. Line 15. Okay, so it doesn't like. This is a char, isn't it? Oh, but this is probably not an unsigned char. Can I just claim it is? That's kind of weird. Like, all right, what if I don't care about whether it's signed or not? Because I don't. All right, so that says they're equal. That's not good. Oh, I said so C1 greater than C2, or if C2 is less than C2. So yeah, good thing I tested that. Okay, now it says that hello is less than hello or hell x because O is less than X. Okay, now say let's do it like that. Now it's saying that hell is greater than O. I don't think that's the case. No, wait, what was it? One is greater than. Is a longer string greater than a shorter string? I actually don't know. The Perl says they're equal. That doesn't seem right either. So everything's equal? Oh, I'm using Perl wrong. This is an integer comparison. Okay. Alright, well, it agrees with this, so I guess this is fine. Oh, yeah, I guess the way this would work is that C2 would be in the null byte in that case. So it's reading off the end of the second string into the null byte if the second string is less than the first string, but that just happens to work. I guess the logic works for that still. So that's why it's not a bug, even though that seems like something you might want to avoid. But yeah, this is completely unsafe. Like you could have written this in C, like within these, just call that instead. But here it is in ATS. And one reason to do it in ATS and not in C, even if you do want to be completely unsafe, is that you can still use like templates in ATS, and you still benefit from, there's still ways you can benefit from ATS. The big one is templates, and also just having a nicer language. As it says right here. However, writing ATS code in C style can often have advantages over writing C code directly. For instance, there's direct support in ATS, but not in C for implementing function templates. In C, one is essentially forced to rely on a rather involved use of macros to implement them, which makes code difficult to follow and also error-prone. Here's another example I'm not going to go into. But yeah, I'd rather have unsafe use of lists than doing lists in C for sure. All right, and so generally you're going to be using C code in ATS or pulling stuff into ATS, but you can also make stuff available to C from ATS. Doing that with functions is really, really easy. Like you just say, Mac like that. And okay, now C code that's linked into this can call strcomp. Well, let's call it ATS strcomp for reasons. So now C that's linked into this can call ATS strcomp and it'll get your function. So exporting functions from ATS to C is very easy, and again, there's no overhead. You just got to make sure that C can handle the types. But if you're exporting like values or data types or types into C, then that's a little bit weird. And this is actually the part of the chapter that I'm less clear on. However, even reading through it, like I didn't really get a good sense of it. So I think this is something if you're going to do this, you'd probably want to write a few test programs and make sure that things really do work as you expect them to. But that's if you're going to do stuff like export data types and export data structures to C. If you're just going to do something simple or if you're going to use structures that are in C, then it's a lot easier. And then constructing a statically allocated list. This is array syntax. So the saying var nodes, the type of the array is a list node. Like there's the elements of the array a list node, and you have n of them, which has to be statically known. So there's 10 of them. And just creating an array that way. I'm not quite sure the differences between saying nodes equals this versus saying nodes and giving the type as the array. It might change like how it's created. Anyway, that is the end of the chapter. So I said most of the chapter is pretty clear, but the last chapter on like using ATS types and ATS types and data structures from C is a little bit odd. But that's something you might want to go through. You're gonna have to go through that yourself and be clear about it. But everything else it's just really straightforward, really easy. And just know that there's no overhead, and the difficulty is not so much in just using it. Like you can take any kind of C library and immediately make use of it in ATS, and there's not going to be any overhead. There's not going to be any difficulty in getting it to work. And even if it has like weird stuff like, oh, well, this pointer might be null, depending on the return type, you can just make your own wrapper for that. It's like, okay, here's a crazy, extra and fun blah equals. Okay, we'll call it whatever crazy thing in C, and then let's say that's like a unsafe blah. And then you make your own, say you go either blah or safe blah, and then this can wrap around the C function and then handle that weird stuff without exposing it to your callers. So you can generate your own overhead in order to make C's interfaces a little bit saner in terms of ATS. Now, if you want to use weird stuff in C directly and still be safe and still handle weird cases like a pointer is set to null conditionally based on the return type of the function or the return of the function. So if the function returns 0, then this pointer is valid. If it returns anything else, the pointer is not valid. If you want to handle stuff like that, that gets into dependent types, and that's a lot. That can be a lot of intellectual work in order to make it correct. But you don't have to make it correct. You can just wrap around it, and you can be productive very easily, is what I'm saying. All right, that's the end of the video.